तर चॅप्टरचं नाव आहे इलेक्ट्रोस्टॅटिक्स. तर स्टॅटिक्स म्हणजे स्टेशनरी आणि इलेक्ट्रो याचा अर्थ ते इलेक्ट्रिक चार्जेस. तर थोडक्यात स्टॅटिक इलेक्ट्रिक चार्जेस याच्याबद्दल हा चॅप्टर आहे. 11वी मध्ये याची थोडी इंट्रोडक्शन झाली होती. त्याच्यामध्ये आपण तो गॉस थिअरम नावाचा एक थिअरम शिकलो होतो की टोटल नॉर्मल इलेक्ट्रिक इंडक्शन ओव्हर अ क्लोज सरफेस is equal to the number amount of charge enclosed by that surface. तर इथे सर्वात पहिल्यांदी त्या गॉस लॉच्या ॲप्लिकेशन्स आहेत आणि त्याच्यानंतर स्टॅटिक इलेक्ट्रिसिटीतल्या बाकीच्या गोष्टी आहेत. So in 11th standard we have studied the Gauss's law, which gives us relationship between electric charge and the electric field. थोडक्यात Q आणि E या दोन गोष्टीतलं रिलेशन. It also provides equivalent methods for finding electric field intensity by relating values of field at the closed surface and the total charges enclosed by that surface. It's a powerful tool which can be applied for calculation of electric field when it originates from the charge distribution of sufficient symmetry. त्याचा मॅथमॅटिकल फॉर्म आहे phi. Phi is the total flux. Phi is equal to Q upon epsilon 0 is equal to integration over a closed surface E bar dot ds bar. आता हे जे सगळे सिम्बॉल आहेत याच्यामध्ये phi stands for the total flux enclosed by that closed surface and Q is the total charge inside the surface. तर फ्लक्स म्हणजे काय? फ्लक्स म्हणजे नंबर ऑफ लाईन्स ऑफ फील्ड इमर्जिंग फ्रॉम अ सरफेस. म्हणजे जसा पाण्याचा फ्लक्स म्हणजे काय, तर पाण्याचा प्रवाह, तसा हा त्या इलेक्ट्रिक फील्डचा प्रवाह. तर तो फ्लक्स जो आहे दॅट इज इक्वल टू Q अपॉन epsilon 0 is equal to integration E bar dot ds bar. So this is the mathematical representation of Gauss law. So let us first write that mathematical form and then we will proceed further. So flux is equal to, that is phi is equal to Q upon epsilon 0, that is equal to integration over a closed surface E bar dot ds bar. So we can apply this Gauss law for finding the electric field intensity of symmetric surface like sphere or cylinder or other symmetric surface. So first we will find the electric field intensity due to uniformly charged spherical shell or hollow sphere. Electric field due to hollow sphere or uniformly charged spherical shell. Yes, let us write लिहूया आपण. इलेक्ट्रिक फील्ड ड्यू टू uniformly charged spherical shell. So we'll consider a sphere. तर असं ऐकू येते का तुला, का आवाज कमी येतोय माझा?
येतं आहे ऐकू.
येत आहे ना. तर
हो
मायक्रोफोन असा वरती धरायची गरज नाही. ठीक आहे.
हो चालेल.
तर असा एक चार्ज स्पियर आहे की ज्यांनी अशा प्रकारे युनिफॉर्म चार्ज कॅरी केला. So consider a spherical shell of radius capital R. या spherical shell ची radius capital R आहे. Its center is situated at point O. Let it carries a charge of density sigma. So sigma is what? Sigma is surface charge density of that surface. That is charge per unit area. Then epsilon is the permittivity of the medium, is equal to epsilon 0 k, which is equal to permittivity of medium. मॅग्नेटिक फील्ड आणि इलेक्ट्रिक फील्ड यांच्या बाबतीमध्ये हे दोन कॉन्स्टंट्स असतात आणि ते अनुक्रमे त्यांना परमिटिव्हिटी आणि परमिएबिलिटी असं म्हणतात. सो लेट अस सी व्हॉट इज, हे पण 11वी मध्ये आपण शिकलो होतो. सो लेट अस सी व्हॉट इज परमिटिव्हिटी ऑफ अ मीडियम. So permittivity meaning, permittivity is the ability of the material to store electric potential energy under the influence of the electric field measured by the ratio of the capacitance of the capacitor with the material as dielectric to its capacitance with vacuum as the dielectric. म्हणजे एखाद्या माध्यमाची इलेक्ट्रिकल पोटेन्शियल एनर्जी साठवून ठेवण्याची क्षमता म्हणजे परमिटिव्हिटी. It measures the opposition offered against the formation of electric field. It is represented by the Greek letter epsilon. It tells the number of charges required to generate unit flux in a given medium. हे थोडक्यात दिलेल्या माध्यमाची इलेक्ट्रिक पोटेन्शियल एनर्जी साठवून ठेवण्याची क्षमता म्हणजे त्याची इलेक्ट्रिकल परमिटिव्हिटी. आणि epsilon 0 म्हणजे परमिटिव्हिटी ऑफ द फ्री स्पेस और द परमिटिव्हिटी ऑफ द vacuum. So consider a sphere of charge of radius r with a uniform charge density sigma. Then the medium has the permittivity epsilon. So how much is the total charge enclosed in the sphere? Total charge enclosed in sphere is equal to surface charge density multiplied by the area of the sphere. and which is equal to this sigma into 4 pi r square, isn't it? Because 4 pi r square is the surface area of a sphere.
Yes.
So
Hmm.
surface charge density into surface area is equal to the total charge enclosed by that spherical surface. Now by Gauss's law, net flux through the closed surface, by Gauss's law, GAUSS, the total electric flux is equal to Q upon epsilon 0, and here Q is nothing but sigma into 4 pi r square, isn't it? आत्ताच आपण म्हटलं तसं 4 pi r
Oh.
square upon epsilon. Now to find the electric field intensity around this sphere, we consider a Gaussian surface. Gaussian surface is an imaginary surface. So here we consider a spherical Gaussian surface around that charge sphere, which is concentric with the given surface and which has a radius small r, which radius is small r. And we consider a point P on this surface where we will find the electric field intensity. या point P ला आपल्याला electric field intensity find करायची आहे. So we consider a small surface ds on this Gaussian sphere. To find the electric field intensity at point P at a distance small r from the center, we imagine a concentric Gaussian sphere of radius small r which passes through P. Then we consider a very small area ds around point P on the Gaussian surface. Due to the symmetry and the spheres being concentric, electric field at each point on the Gaussian surface has same magnitude and it is directed radially outward. आता इथे जे इलेक्ट्रिक फील्ड असेल, it will be like this, isn't it? It will be emerging out of this sphere, like this, the electric field. We want to measure the electric field of this spherical charge surface at point P, which is at a distance small r from the center. So we have phi is equal to Q upon epsilon 0 equal to integration E bar dot ds bar. So what is integration E bar dot ds bar? But before that we will write what is ds. So we say that consider a point P at a distance small r from O. Consider a very small area ds around point P. So we have integration E bar dot ds bar, which is equal to integration E ds cos theta theta is the angle between E bar and ds bar. Now angle between E bar and ds bar is 0. आता हे कसं, कुठलाही एरिया वेक्टर असतो, त्या एरिया वेक्टर ची जी डायरेक्शन असते दॅट इज इमर्जिंग आउट ऑफ दॅट एरिया. त्या एरियामधनं ती अशी
हम्म.
इमर्ज आउट होते, बरोबर की नाही? आणि इलेक्ट्रिक फील्डची पण तीच दिशा आहे. करेक्ट. कुठलाही जरी
Yes.
आपण एरिया वेक्टर कन्सिडर केला, त्या एरिया वेक्टरची डायरेक्शन ही त्या सरफेसला परपेंडिक्युलर असते. सो इथे अशा प्रकारे त्या डीएस ला परपेंडिक्युलर जर काढला आपण, तर त्याची डायरेक्शन आणि इलेक्ट्रिक फील्डची डायरेक्शन दे आर सेम, बट थीटा इक्वल टू 0. सो cos theta is equal to cos 0 equal to 1. In that case, e bar dot ds bar किंवा इंटिग्रेशन e ds
Hmm.
cos theta is equal to integration e ds, कारण cos theta is equal to 1.
Yes.
Now the electric field is constant at all points at distance r. So we can take that constant out of the integration sign and it will be e into integration ds. Integration ds is integration of that small surface area over the entire sphere, and that is equal to 4 pi small r square. So it is e into 4 pi small r square. So as phi is equal to 4 pi r square sigma upon epsilon 0 is equal to integration e ds is equal to e into 4 pi small r square. So from that we can write E is equal to 4 pi r square sigma upon epsilon 0 into 4 pi small r square. So 4 pi cancel. So that is equal to sigma capital R square upon epsilon 0 small r square. So this is the expression for the electric field intensity. It can be seen that the electric field at a point outside the shell is same as that of the point charge. It can be concluded that a uniformly charged sphere is equivalent to a point charge at the center. If the point P lies on the sphere, so electric field on the surface of the sphere, electric field on the surface of the sphere is equal to sigma capital R square, and in this case जर आपला पॉइंट पी जर त्या स्पिअर वरती असेल तर स्मॉल आर इज इक्वल टू कॅपिटल आर, इजंट इट?
Yes.
तो हे आर आर कॅन्सल, आर स्क्वेअर कॅन्सल, सिग्मा अपॉन एप्सिलॉन 0. So in that case the electric field is sigma upon epsilon 0. And if the point P lies inside the sphere, since there are no charges inside the sphere, then sigma equal to 0, so that electric field will also be equal to 0. कारण कुठल्याही काय चार्ज सरफेस वरती all the charges are present on the surface of that object. So inside there is no electric charge, and as there is no electric charge, sigma will be 0 inside, so E will also be equal to 0 inside. So this is the
Yes.
expression of electric field due to a charge sphere. Similarly, we can find the electric field due to an infinitely long cylinder. So consider a uniformly charged wire of infinite length having a constant linear charge lambda. So lambda here it is the linear charge density, or it is Q upon L, again kept in a permittivity of epsilon. तर हे समजलं. स्पियरच्या बाबतीत.
हो.
तर असंच आता सिलेंडरच्या बाबतीत.
बुकमध्ये इंटिग्रेशनचे साइन अशी का दिले?
हा, ते इंटिग्रेशन ओव्हर क्लोज्ड सरफेस असं आहे. हे असं
इंटिग्रेशन ओव्हर
क्लोज्ड सरफेस,
ओके.
क्लोज्ड सरफेस थोडक्यात बंदिस्त पृष्ठभागावरती. म्हणजे आता स्पियर आहे, एखादा फुटबॉल कन्सिडर कर, तर फुटबॉल इज अ क्लोज सरफेस ना, तो सगळीकडनं एकमेकाला जोडलेला आहे असा, म्हणून
ओके.
ते असं म्हटलं आहे. ओके. Now, electric field due to infinitely long straight cylinder. Electric field due to infinitely long cylinder. Again, we will consider infinitely long cylinder like this, and we will find that the electric field near the surface of the cylinder. So this is infinitely long wire like this. Then we will consider a point R situated at a distance small r from its center. Radius of this cylinder is capital R again. So here we consider the Gaussian surface to be equal to a cylinder of radius small r around that point P. So here we have point P, and here we consider a surface around it, ds. So what we will write, consider a uniformly charged wire of infinite length. Consider a uniform wire किंवा cylinder, wire with infinite length let its linear charge density equal to lambda, kept in a medium of permittivity epsilon, kept in a medium of permittivity epsilon, sorry चुकून lambda म्हटलं, epsilon equal to epsilon 0 k. So we want to find the electric field intensity at point P, which is at a distance small r from the center of this. So we consider a coaxial Gaussian cylinder of length L. Consider coaxial Gaussian cylinder of length L around that cylinder, around that wire. Consider a coaxial Gaussian cylinder of length small l and radius r around wire. Consider a point P on the wire sorry uh, on that cylinder. On the Gaussian surface. So by symmetry, the magnitude of electric field will be same at all points on the curved surface of the cylinder and will be directed radially outward. Again, see the vector ds bar will be like this, radially outward, and the electric field will also be in the same direction, isn't it, radially outward. So
Yes.
angle between E bar and ds bar will again be equal to 0. This is E bar. So by Gauss theorem, flux phi is equal to q upon epsilon 0. Now q is equal to lambda into L, okay, upon epsilon 0, where lambda is linear charge density. Linear charge density म्हणजे काय, कूलम पर मीटर. मग जर लेंथ स्मॉल एल असेल तर इट विल बी लॅम्बडा इंटू स्मॉल एल. Yes. So now this is equal to integration E bar dot ds bar so integration E bar dot ds bar is equal to, over the closed surface of that cylinder, equal to integration E ds cos theta theta is the angle between E bar and ds bar, which is 0. Theta is the angle between E bar and ds bar. Theta is equal to 0, so cos theta is equal to 1. So again phi is equal to q upon epsilon 0 equal to lambda L upon epsilon 0 is equal to integration EDS. Again cos theta is 1. So we have lambda L upon epsilon 0 is equal to, E can be taken out of the integration sign because it is constant, into integration ds. That's why lambda L upon epsilon 0 is equal to E. Integration ds is nothing but the area of the cylinder, surface, curved surface area of the cylinder. And what is curved surface area of the cylinder? It is 2 pi RL. That is equal to 2 pi RL. 2 pi RL is curved surface area, CSR, of cylinder. So what we can write here? So here LL can be cancelled out. So you get the expression for electric field intensity around an infinitely long wire to be equal to, E is equal to, we have lambda upon हे बाकी 2 पाय आर इकडे गेले, लॅम्बडा अपॉन 2 पाय आर epsilon 0 किंवा 2 पाय आर epsilon 0 आर काही लिहित चालेल. So this is the expression of electric field intensity around the infinitely long wire. So for
Okay.
sphere it is sigma r square upon epsilon 0 small r square. For the wire it is lambda upon 2 pi epsilon 0 r. The direction of electric field is directed outward if lambda is positive and inward if lambda is negative. So there is one more uh, application, and that is the electric field due to a charge infinite plane sheet. हे
Okay.
हे दोन्ही समजले डेरिवेशन्स.
हो.
Now the electric field intensity due to an infinite charge plane sheet.
अच्छा.
Electric field due to charge infinite plane sheet. So we'll consider an infinite plane sheet like this. It carries a charge uniform. Like this. And we want to find that the electric field at point P, which is at a distance small r from the sheet. So this distance is small r from the sheet. We consider a Gaussian surface in the form of a cylinder around that point. This is such cylinder. So consider a uniformly charged infinite plane sheet with surface charge density sigma. By symmetry, electric field is perpendicular to the plane sheet and it is directed outward, having same magnitude at given distance. Let P be a point at a distance r from the sheet. E is the electric field at P. So we'll write, consider an infinitely charged plane sheet. Consider an infinite long plane sheet with surface charge density sigma. Then consider a point P at a distance small r from the sheet. Then we consider a Gaussian surface around point P in the form of a cylinder having a cross-sectional area ds and length 2r with its axis perpendicular to the plane sheet. Consider a Gaussian surface in the form of cylinder having cross section area ds and length 2r passing through surface with axis perpendicular to surface. So by symmetry, electric field is at right angles to the end cap and its magnitude is same at the point P, and if we consider that point P dash. So electric field at point P is equal to electric field at point P dash. The magnitude of the two electric fields are same. Total flux enclosed by the surface. So if we want to find phi, that is equal to integration EDS around point P plus integration EDS around point P dash. So that is equal to EDS plus EDS, that is equal to 2 EDS. So sigma is what? Sigma is surface charge density. So by Gauss's law, we can say that by Gauss theorem, phi is equal to Q upon E0, that is equal to sigma ds upon epsilon 0 is equal to 2 EDS. ds cancels on both sides, and that gives us the electric field intensity E is equal to sigma upon 2 epsilon 0. So this is the electric field intensity around an infinitely plane surface. तर अशा प्रकारे तीन आपण याच्यामध्ये डेरिवेशन बघितली. फर्स्ट म्हणजे इलेक्ट्रिक फील्ड इंटेन्सिटी नियर चार्ज स्फियर, नियर a charge cylinder, and then near an infinitely plane surface. परीक्षेत विचारायचं लिहिता येईल असं 2-2 मार्काला येऊ शकतं. फाइंड द एक्सप्रेशन फॉर इलेक्ट्रिक फील्ड अराउंड अ चार्ज sphere or a charge cylinder or infinitely charged application. 3 न्यूमेरिकल्स आहेत बघ, एकदम बघू आपण. ऍप्लिकेशन ऑफ फॉर्म्युला आहे, मग अशी स्किप केली होती. सगळ्यात पहिलं काय बघ, न्यूमेरिकल पुढे गेला 8.1. ओके, वाच बरं काय लिहिलं.
A sphere of radius 10 centimeter carries the charge of
1 microcoulomb. So mu आहे ना, mu stands for micro. Micro म्हणजे 10⁻⁶.
1 microcoulomb. Calculate the electric field. First, at a distance of 30 centimeter from the center of sphere. Second, at the surface of the sphere, and third, at the distance of 5 centimeter from the center of the sphere.
तर आपल्याला गिवन काय इथे आता आपल्याला सिग्मा नाही दिली, इथे आपल्याला दिलाय क्यू दिलाय. क्यू म्हणजे काय, टोटल चार्ज
Total
enclosed by that surface, which is
charge.
equal to 10 raised to minus 6 coulomb. So
Yes.
electric field intensity at a distance small r is equal to E equal to Q upon 4 pi epsilon 0 into small r square. स्मॉल आर दिला आपल्याला 30 सेंटीमीटर, 30 सेंटीमीटर म्हणजे 0.3 मीटर. आता हा जो epsilon 0 आहे, दॅट इज परमिटिव्हिटी ऑफ द फ्री स्पेस, याची किंमत असते 8.85 इंटू 10 रेज टू मायनस 12. पण इथे आपल्याला दिलाय 1/4 पाय epsilon 0. तर epsilon 0 ची किंमत असते 8.85. हॅलो,
येत आहे.
येत आहे ना ऐकायला? हां, 8.85 इंटू 10 रेज टू मायनस 12. 8.85 इंटू 10 रेज टू मायनस 12. ठीक आहे. आता आपल्याला 4 पाय epsilon 0 हवं आहे. याला 4 ने मल्टिप्लाय करू आणि मग याला पाय ने मल्टिप्लाय करू. दिस, आणि याचा जर आपण रेसिप्रोकल काढला, याला आपण 1/4 पाय epsilon 0 पाहिजे ना, 1/x काढला. इट इज अप्रॉक्सिमेटली इक्वल टू 9 इंटू 10 रेज टू 9. 899180469 आलाय बघ. 10 रेज टू 1 2 3 4 5 6 7 8 आणि 9, म्हणजे 8.99 इंटू 10 रेज टू 9 येईल. सो अप्रॉक्सिमेटली यू कॅन टेक इट ॲज 9 इंटू 10 रेज टू 9. ओके, म्हणजे जिथे जिथे आपल्याला 1/4 पाय epsilon 0 असं एक्सप्रेशन मिळेल, तिथे आपण त्याच्याऐवजी काय लिहू शकतो, 9 इंटू 10 रेज टू 9. ओके, 1/4 पाय epsilon 0 ची किंमत. सो 1/4 पाय epsilon 0 त्याच्याऐवजी लिहिलं 9 इंटू 10 रेज टू 9. क्यू किती आहे, क्यू इज 10 रेज टू मायनस 6 अपॉन आर किती आहे, 0.3. सो if you calculate, it will come 1 lakh Newton per coulomb. On the surface of the sphere काय येईल, the distance will be equal to 10 centimeter. So it is means that value of small r is equal to capital R. So we'll put 0.1 square over there, and that will give us 9 into 10 raised to 5 Newton per coulomb. At a point 5 centimeter, now the radius of the sphere is 10 centimeter and the point is at 5 centimeter. That means in the third case, the point lies inside the sphere, and inside the sphere there is no electric field, no electric charge. So no electric charge, no electric field. All the charges are present on the surface. So inside the sphere, electric field will be 0. असं आपण सॉल्व करू शकतो. आता 8.2 काय वाच.
The length of a straight thin wire is 2 meters. It is uniformly charged with a positive charge of 3 microcoulomb. Calculate the charge density of the wire and the electric intensity due to the wire at a point 1.5 meter away from the center of
ओके, आता इथे आपल्याला लॅम्बडा दिलेलं नाहीये. सो लॅम्बडा इज नथिंग बट लिनियर चार्ज डेन्सिटी. सो लॅम्बडा इज इक्वल टू क्यू अपॉन एल. क्यू आपल्याला दिलाय, क्यू इक्वल टू 3 microcoulomb. So 3 into 10 raised to minus 6 coulomb upon 2, because length is 2 meter. So lambda किती आला आपला, 1.5 into 10 raised to minus 6 coulomb per meter. And what is the distance? Distance is 1.5 meter. So r, small r is 1.5 meter. So we can use the formula. What formula? कि E is equal to lambda upon 2 pi epsilon 0 into r. Correct. सो लॅम्बडाची व्हॅल्यू लिहिली 1.5 इंटू 10⁻⁶ अपॉन 2 ची व्हॅल्यू लिहिली इंटू पाय दॅट इज 3.142 आणि इथे 9 इंटू 10⁹ च्या ऐवजी आपण ॲप्सिलॉन 0 ची व्हॅल्यू टाकली 8.85 इंटू 10⁻12 into smaller is 1.5. So if you calculate the value, it will give us 1.798 into 10 raised to 4 Newton per Coulomb. So it will be 17,980 Newton per Coulomb. Same आता the third numerical.
Third.
हे काय लिहिलंय बघ.
The charge per unit area of a large flat sheet of charge is 3 microcoulomb per meter square.
म्हणजे आपल्याला सिग्मा दिलाय इथे. सिग्मा इज व्हॉट? सरफेस चार्ज डेन्सिटी.
Calculate the electric field intensity at a point just near the surface of the sheet, measured from its midpoint.
So here we have the formula E is equal to sigma upon 2 epsilon 0. Sigma दिलाय आपल्याला 3 into 10⁻⁶ upon 2 epsilon 0 ची व्हॅल्यू दिली आहे 8.85 into 10⁻12. So if we calculate it, it will give us 1,70,000 Newton per Coulomb. So this was about the applications of the Gauss theorem. Now the next topic is electric potential and potential energy. What is potential energy? What is gravitational potential energy? Gravitational potential energy is the energy stored in the object by virtue of its position or the configuration. म्हणजे वस्तूची स्थिती किंवा वस्तूची रचना यांच्यामुळे जी एनर्जी त्या वस्तूमध्ये साठली जाते, स्टोअर केली जाते, त्याला म्हणायचं ग्रॅव्हिटेशनल पोटेन्शियल. सिमिलरली analogy आहे. Similarly we have that electric potential and electric potential energy. So we have studied earlier that the potential energy of a system is the stored energy that depends upon the relative positions of the constituents. Electrostatic potential energy is work done against the electrostatic forces to achieve certain configuration of charges in a given system. Since every system tries to attain the lowest potential energy, work is always required to be done to change the configuration. म्हणजे त्या चार्जेसची रचना करण्यासाठी जे आपल्याला वर्क डन करायला लागतं ते वर्क डन त्याच्यामध्ये इलेक्ट्रिक पोटेन्शियल एनर्जीच्या रूपामध्ये स्टोअर होतं. आता हे वर्क डन का करायला लागतं? तर वर्क डन याकरता करायला लागतं की लाईक चार्जेस विल रिपेल इच अदर अँड द अनलाईक चार्जेस विल अट्रॅक्ट इच अदर. म्हणजे एखाद्या ठिकाणी एखादा चार्ज समजा आहे प्लस क्यू आणि दुसरा चार्ज प्लस क्यू तिथे आणून बसवायचा असं आपण म्हटलं तर ते बसवण्याकरता आपल्याला रिपल्शन ओव्हरकम करायला लागेल, कारण ते दोन एकमेकाला लांब ढकलायचा प्रयत्न करतील आणि त्याच्या अगेन्स्ट आपल्याला वर्क डन करायला लागेल की त्या ठिकाणी ते स्टोअर होते. हे जे दोन अनलाईक चार्जेस असतील तरी एकमेकाला अट्रॅक्ट करायचा प्रयत्न करतील ते. त्यामुळे त्यांना एका ठिकाणी ठेवायला किंवा त्यांची एक रचना बनवायला, एक त्यांचं कॉन्फिगरेशन बनवण्याकरता आपल्याला वर्क डन करायला लागेल. आणि हे जे वर्क डन असतं दॅट इज कॉल्ड द इलेक्ट्रिक पोटेन्शियल energy. A charge exerts a force on any other charge in its vicinity. Some work is always done to move a charge in presence of another charge. This potential energy arises from the collection of charges. म्हणजे एकाच चार्जची आपण पोटेन्शियल एनर्जी आपण डिफाइन करू शकत नाही. Whenever there is a collection of charge, there are many charges, then those charges interact with each other and this gives rise to the electric potential energy. So consider a charge q fixed at some point in space. For bringing another positive charge close to it, work is necessary. This work is equal to the change in the potential energy of the system. Thus work done against the electrostatic force is equal to increase in the potential energy of the system. F bar dot dr bar equal to du. Du is the change in the potential energy when the charge is displaced through dr bar, and F bar is the force exerted on the charge. So we'll find the expression for this potential energy. Let us consider an electrostatic field due to a source charge plus Q placed at the origin O. Let a small charge plus Q0 be brought from point A to B at a respective distances R1 and R2. म्हणजे आधीचं डिस्टन्स R1 होतं, नंतरचं डिस्टन्स R2 आहे, आणि R1 पासून R2 पर्यंत तो चार्ज आपण मूव्ह केला against the repulsive forces on it, because the two charges are like charges and so they will repel each other. Work done against the electrostatic force Fe in displacing the charge Q0 through a small distance dr bar appears as an increase in the potential energy of the system. So du is equal to Fe bar dot dr bar is equal to Fe into dr with the minus sign. Negative sign appears because the displacement dr bar is against the electrostatic force. For the displacement of the charge from the initial position A to the final position B, the change in potential energy is delta U. So delta U is equal to integration R1 to R2 du, that is integration R1 to R2 minus FdR. The electrostatic force, the Coulomb force between the two charges separated by distance r is F is equal to that Q into Q0 upon 4 pi r square. So Fe is equal to minus 1 upon 4 pi epsilon 0 Q0 upon r square into r cap, where r cap is a unit vector along the direction of r bar. Negative sign shows that r bar and Fe bar are oppositely directed. So if the two charges are the positive charges, they will repel each other, and hence the work has to be done against this repulsion. For a system of 1 point charge, delta U, that is change in potential energy, equal to integration R1 to R2 of du, that is integration R1 to R2 of minus 1 upon 4 pi epsilon 0 Q0 upon r square into r cap into dr bar. This 1 upon 4 pi epsilon 0 is a constant that is taken outside, into Q0 integration 1 upon r square into dr. So r raised to minus 2 into dr. Okay. Here what we have to do? We have to do integration 1 upon r square dr. That is r is raised to n minus 1, that is minus 2 plus 1 upon minus 1. So that is equal to r raised to minus 1 upon minus 1, that is equal to minus 1 upon r. And this is over the limit r1 and r2. That is 1 upon r2 minus 1 upon r1. So delta U is 1 upon 4 pi epsilon 0 Q0, product of the two charges, 1 upon r2 minus 1 upon r1.
Okay.
So this is the definition of electric potential. The change in the potential energy depends upon the end points R1 and R2. म्हणजे आधी तो चार्ज R1 ला होता, नंतर आपण तो R2 ला आणून ठेवला, तर हे ट्रान्झिशन करण्यामध्ये जे वर्क डन झालं that is equal to 1 upon 4 pi epsilon 0 q0 1 upon r2 minus 1 upon r1. It is independent of the actual path की r1 पासून r2 पर्यंत कुठल्या मार्गाने तो चार्ज केला, that is not important, only that the initial point and the final point, they are important. So this is the change in electric potential energy, 1 upon 4 pi epsilon 0 q0 1 upon r2 minus 1 upon r1. So this is the electric potential. Now, until now it is convenient to choose infinity to be the starting point. So the potential energy of a system of 2-point charges q1 and q2 separated by a distance r can be obtained by the above equation as r1 equal to infinity, r2 equal to r. So it is equal to ur is equal to 1 upon 4 pi epsilon 0 q1 q2 upon small r. ठीक आहे, इथपर्यंत समजलं?
हो.
ओके, आज थांबूया इथे. उद्या एक्सप्रेशन्स याचं शोधूया आणि नंतर मग इलेक्ट्रिक पोटॅन्शियलचं डेफिनेशन देऊया आणि मग सिस्टीम ऑफ चार्जेसमुळे निर्माण होणारे इलेक्ट्रोस्टॅटिक पोटेन्शियल अशा प्रकारे पिऊया.
चालेल.
ओके, इथपर्यंत कळलं?
हो.